from the in to the outside.
Right now I'm trying to measure the resonance frequency of this driver. So I've made this little setup that's to keep this driver in the air, and put that stuff here to stop it from resonating around, because you don't want to have like big things around this drive, so it should be in mid-air a little bit. Obviously this won't affect it that much. You still need to secure it on some sort of way, and then I've made this little setup. So I have a high-effects plate I'm sitting here with a cable that's going to the side part, so it's reliable enough. And you have a multimeter. Then the plus is just regularly connected to the amp, and the minus of the driver you should put a resistor, a barrel. This should be around 5 watts. I have a 10 watt resistor over here, and you should have the red lead should go, it's in here, you see the driver, then you have the red lead, then it goes through the resistor, black lead, and then goes to the minus of the amp. So it's really simple. Just show you a small diagram. You should make this little setup should do it. And obviously there are some ways some formulas that will give you the rest of the information. But I'm planning to make a transmission line enclosure for this driver, so I don't need really that much information about this driver. The resonance frequency and the SD, the service area of the driver, is enough for a standard C line. Obviously I made it a little bit more precise with the 10 band driver, but this is just a little driver, a little product for fun. So right now I have the frequency set to 70 Hertz, and you can see we have 0.5 volts, 0.6, so I'm going to drop it, and it should drop. So now we have 0.5. So on 17 Hertz we were between 0.5 0.6. Now on 68 Hertz we have 0.5. As you can see, I'm now on 65 Hertz, and the voltage dropped again to 0.4. So yeah, 62 Hertz, 0.3 volts. So that's 59 Hertz, 0.2 volts. And and on 56 Hertz and still 0.2 Hertz. 54, still 0.2. 53, still 0.2 volts. Now you can see it's raised again on 52 Hertz. The table begins to vibrate on 51 Hertz. You can see now we're on 43 Hertz, but everything 48, so 5 volts. It's 52, 51 volts. You see in the end I decided to put like all those frequencies versus the voltages in Excel because it wasn't really clear. But as you can see, that's 55.5 Hertz, and I was expecting 55 Hertz, so I wasn't far off already. I could just have made the T9 already, but now I know it's around 55.5 Hertz. I can make it even more precisely. So I'm just going to make a regular T-line, so that means 340 meters a second, speed of sound, and I'm going to divide it by the resonance frequency of the driver times 4. It gives me around a length of 1.45 meters after I have removed some of the length, because you need to take off around 5%, because length is always a little longer than it should be.